Good morning, my name is Charles Andrew Anthony and my matrix number is 0DTP21F1020. Okay, mold. What is plastic injection molding process? Plastic injection molding is a process of melting plastic pellets, thermosetting thermoplastic polymers that once malleable enough are injected at the pressure into a mold cavity which fills and solidifies to produce the final project. Also, plastic injection molding is present in many commercial construction applications, including conduits for concrete beams, insulation materials, and especially flooring panels. Other includes roofing vents, drainage components, and railing gaskets. Compare injection mold and plastic process. There are four types of plastic process: injection, transfer, extrusion, and blow molding. Injection molding. Injection molding is a process which thermoplastic polymer is heated above its melting point, resulting in the conversion of a solid polymer to a molten fluid with reasonably low viscosity. This melt is mechanically force that is injected into mold in the shape of the desired final object. Transfer molding is a process of forming components in a closed mold from a thermostatic material that is conveyed under pressure in a hot plastic state from auxiliary chamber called transfer port through runners and gates into the closed cavity or cavities. Extrusion molding is used to form plastic or metal material into a predefined shape. During process, the material is melted and pushed through an extrusion molding machine, forming a long tube-like shape or rod. This is cooled and cut into required length. Last, blow molding. Blow molding is a manufacturing process for forming hollow plastic part. It is also used for forming glass bottle or other hollow shape. In general, there are three main types of blow molding: extrusion, injection, and injection blow molding. Injection blow molding. The blow molding process begins with softening plastic by heating a preform or parison. The parison is a tube-like piece of plastic with a hole in one end through which compressed air can enter. Okay. Defect of plastic injection molding. Sink mark. This type of injection plastic defect occur as small depression or recesses. These features occur on flat and consistent surface of molded parts. Sink marks usually occur when there is a shrinking of molded components in a part. This causes the material to pull inward from the outside. Burn marks. This injection molding defect appears as black discoloration on the surface of the molded part. The molded plastic part may also appear to be rust-colored. Burn marks do not generally affect the integrity of parts. However, it becomes a problem when the part gets burned to a level of degradation. There are 10 more defects that I didn't say, which is splay, flow line, welt lines, flash, jetting, vacuum void, shot, warping, and surface delamination. Apply mold design in initial consideration. Shot weight. Shot weight is the amount of material injected into the mold to fill the mold, including the feed system. Shot weight, on the other hand, is the sum of the sprue, runner, and gate weight. Clamping necessary. A measurement of the force needed to hold the mold closely during injection. If this pressure is not set high enough, the mold will be forced open prematurely by injection pressure and will create flash on the related part. Molding cycle. The sequence of the event during injection mold of a plastic part is called the injection molding cycle. The cycle begins when the mold closes, followed by the injection of the polymer into the mold cavity. Once the cavity is filled, holding a pressure maintained to compensate for material shrinkage. Number of impressions to be included in the tool. The number of impression or cavities to be included in an injection molding tool or also known as a mold or die. Position and type of feed. The feed refers to how and where the molten plastic is introduced into the mold cavity. Properly designing the feed system is crucial to ensure that the mold can produce high-quality parts. Mold opening force. The force required to separate two halves of mold, typically in injection molding or die casting process. Sketch type of injection mold. Two-plate mold and three-plate mold. Two-plate mold are a mostly commonly used type of injection mold. They consist of one parting plane where the mold splits. In a multi-cavity two-plate mold, runner and gate must be in the parting plane to ensure runner and gate's ejection when mold split. Three-plate mold is an injection molding mold that uses a cold runner system. The runner are arranged on two planes. When opening the mold, there are clearance to take out the runner and the other to remove the finished part separately. Two-plate mold can be used to produce a wide range of plastic injection mold products with intricate details such as multi-cavity molds or simple parts with no additional features. This versatility makes them ideal for a variety of industries, including automotive, consumer goods, and medical devices. Function of mold component attached at two-plate mold. Fixed clamping plate or top plate. The fixed clamping plate or the top plate holds the fixed side of the mold to be attached to the fixed plate of the injection molding machine. At this plate will attach placating ring, eyeball, and screw bush. Runner stripper plate. The runner stripper plate is only used in three-plate mold types. The runner stripper plate's function is to cut resin from the nozzle on top of the screw bush and pull the runner by a runner locking pin. Fixed mold plate or cavity plate. The fixed mold plate or cavity plate is used to hold cavity side of the plastic product. Leader pin, support pin, puller ball, and angular pin when the sides are attached. Apply mold design in initial consideration. Core. A core is a device used in casting and molding process to produce internal cavity and return angle, an interior angle that is greater than 180 degrees. The core is normally a disposable item that is destroyed to get it out of the piece. Cavity. Mold cavity is also used to describe the entire space within a mold in which the feedstock is placed to create the desired shape. Parting line. The parting line in industrial casting of mold is the borderline between the two halves of the mold known as the core and the cavity. Feed system in a mold. Screw, runner, and gate. Screw is a vertical passage through which liquid material is introduced into the mold, and it is larger diameter channel through which the material enters the mold. Runner. A runner is a channel cut into the mold that allows plastic material to flow from the nozzle to the cavity. The gate is the opening in the mold through which the molten plastic is injected into the final part. It is the boundary between part and scrap. Ejection system. An ejector pin is an ejector system that pushes the molded part out of the mold cavity after injection. Alongside ejector systems such as ejector blade and block, ejector allowed efficient parts removal after molding. There are several types of ejector pin, which is ejector sleeve, ejector press, and ejector block. Mold shrinkage, taper, and tolerance. Mold shrinkage refers to the dimensional change of the injection mold object as it cool, while plastic shrinkage can be used to refer to the characteristic of a specific plastic. Taper. Mold taper are used to mitigate the contraction of the sulfide shell during cooling. Tolerance. Injection molding tolerance are acceptable variation in size of part, features in and overall dimension. Next. Cooling system. A water cooling system is also known as a hot press. Works by transferring frozen water through pipes running through the mold cavity and outside the runner gate. These water lines will be closest to the outside of the molded product surface to ensure uniform cooling and prevent warping of the product surface. Split side core and side cavity. Split. A mold in which the cavity is formed by two or more parts are held together by a chaste boulder during the ejection phase. Side core: for any undercut region of a plastic molded part, a side core has to be designed to form the complex geometry while avoiding the interference between the injection mold and the plastic molded part. Side cavities: in the mold cavity, a metal working technique in which fine powdered metal is combined with the binder material to create feedstock that is molded and solidified using injection molding, die casting, or forging. Okay, design drawing of the plastic part. I make a Google icon as my plastic part, and this is the two-plate mold of the plastic part. This is the detailed drawing of the mold. This is a three-plate and the assembly of the mold, and this is an exploded of the mold. Describe the sustainability to increase the life and aware of environment. Tool life. Tool life refers to the useful life of machine tool. It can be expressed as the amount of good part that given tool is capable of machining. Way to improve tool life: use appropriate speed and feed. Using the right speed and feed setting will increase tool life significantly. Apply cutting fluid. The right type of cutting fluid and the right amount of fluid application will prolong tool life. Use the right tool. Some workpiece may be strong enough to need a high-speed steel tool. Knowing this parameter will help select the right tool for the combination form factor. Awareness of environment. Environment awareness is a movement that teaches the need for humans to respect and protect the natural environment. Human waste production accumulates in the environment and impacts the soil, wildlife, and water. With the Industrial Revolution, scientists advanced led to production of greenhouse gases that warm the atmosphere and cause gradually increase in temperature, also termed the greenhouse effect. These are the way to protect environment: reduce, reuse, and recycle. Follow the 3 R's to conserve natural resource and landfill space. Shop wisely. Buy less plastic and bring a reusable shopping bag. Plant a tree. Trees provide food and oxygen. They help save energy, clean the air, and help combat climate change. Conserve water. The less water you use, the less runoff and wastewater that eventually end up in the ocean. Conclusion. In conclusion, injection molding stands as a cornerstone in a modern manufacturing, offering a balance between precision, efficiency, and most effectiveness. Its adaptability to various materials and design, along with continuous technological advancements, ensure its continued relevance in diverse industries. In addition, injection molding is used to create many things such as wire spools, packaging, bottle caps, automotive parts and components, toys, pocket combs, some musical instrument and part of them, one-piece chair and small tables, storage containers, mechanical parts including gear, and most of the plastic products available today. Thank you for watching.